Welcome back to A-Star Science. This is part of our GCSE Must Know Chemistry series. Today we're going to be focusing on a topic that is a bit harder. You're going to find it in the more challenging aspects of the course, in particular, those people that are doing separate science, separate chemistry. They're going to need to know this particular topic. It comes up in the ends of the paper, the backs of the paper, and can be somewhat challenging. We're going to look at an easier type of question first, and then we're going to look at a more challenging type question. Okay, so the question is about limiting reactants and yield. First of all, what is a limiting reactant? We need to understand what that means. And a limiting reactant is the reactant that will be used up first. And when we say used up first, we need to understand that it has the least moles. Remember, reactants are those things on the left side of an equation. So the limiting reactant is the one that's going to be used up first because it has the least moles. That's different than the reactant that is in excess. In excess means some will remain behind. It won't be used up. Okay, there's more than enough moles. Will not be used up. There's more than enough moles of those reactants that are in excess. But how do we know which one is the limiting reactant, and how do we know which ones are in excess? That's what this calculation is going to help you with today. So I have a method that I call the table method that you should get used to. It's really helpful for any question that involves calculations, including titration calculations, amounts of substance, and limiting reactants like what we're doing today. This first question comes from the AQA exam board. The first step in my table method is to always rewrite the equation. So in the space that they give you for your answer, we're going to rewrite the equation, which is 2 aluminum plus iron oxide yields 2 Fe plus aluminum oxide. And I'm going to do all of these calculations with you step by step along the way. So the first step is to use the equation, rewrite it out again in your answer space. The second step is to write down what you know. What have they given you in the equation? So they says a mixture contains 1 kilogram of aluminum. So that's going to be the mass, which is 1 kilogram. And we're going to convert that right into grams, because when we're working with moles, we want to use grams as our unit. It says they're giving you 3 kilograms of iron oxide. And of course, that's 3,000 grams. It gives the equation, and then it says show that aluminum, this one here, is the limiting reactant. How do we do that? Well, we need to determine the moles, because we said the limiting reactant is the one with the least moles. So this is a really helpful acronym or saying that I remember for moles. It's Mr. Mole mass. And of course, Mr. here means the molecular mass or the formula mass. So to find moles, we need the mass, which we have, and now we need the MR or the molecular mass. Well, they give it to you here in the equation. So for aluminum, the MR is 27. And for iron oxide, we're going to have to calculate that. So there are 2 irons, 56 times 2, plus oxygen is 16 times 3. Okay, so let's calculate that on the equation. I said I'm going to do all the calculations with you. 56 times 2 plus 16 times 3. And that's going to equal 160. So let's clear the board a bit, give us a bit more space so we can work. That was 160. Now you can see why I call this the table method, because things are being laid out in a table form, and it helps to organize all of your information, and also makes it much easier for teachers to understand and see where they can give you marks. Everything is nicely signposted. So to find the moles, we need to do the mass divided by the MR. So the moles of aluminium is going to be 1,000 divided by 27. Let's see what that is on the calculator, which is 37.037. And then the moles of iron oxide are 3,000 divided by 160. Always put your units in. Really get in the habit of putting your units in. And that's going to be 18.75. So that's how many moles we have of both. Let's recap. We have 37.037 moles of aluminum and 18.75 moles of iron oxide. We're trying to find out the limiting reactant. Which one has the least moles? Now, really importantly, if we look at the top, at the equation, this says there are 2 moles of aluminum to every 1 mole. There's not a number there, but that means 1 to every 1 mole of iron oxide. So we need to have basically double the amount of moles of iron oxide. Okay, so let's look at that. If we take 18.75 times 2, this should be 37.5. That's how much aluminum we would need. And we can see that we do not have 37.5. We only have 37.037. And that means we've answered the question that aluminum is the limiting reactant because there's just not enough moles to react with the iron oxide. So that was an exam question from an AQA GCSE style exam question paper. Let's look at one that's a bit more challenging from BBC Bitesize. So here's an exam question from BBC Bitesize, and the reason this one is more difficult because it does not give the limiting reactant. You have to determine that, as well as it then asks you to find out an unknown mass of one of the products. But the technique I used is the same. You're going to, of course, first write out the equation again. In my table method, space it right out so you have space. And this reaction shows aluminium reacting 2 moles of aluminium, reacting with 6 moles of hydrochloric acid to yield 2 moles of aluminum chloride plus 3 moles of hydrogen gas. The second step is to write down what information you know from the question. Well, they tell you the mass of aluminium, which is 2.7 grams that you're given to work with, reacts with 9.125 grams of hydrochloric acid. So this is our table method coming nicely to shape. We then need to work out the moles present. Of course, to do moles, again, let's remind ourselves, Mr. Mole mass. We need the mass, which we already have, and we need the MR. So the MR of aluminum is 27, and the MR of hydrochloric acid, well, 1 for hydrogen. That's how much it is on the periodic table for its mass, plus 35.5 for chlorine. That's 36.5 for its MR. Well, how many moles? Well, let's use our calculator to figure that one out. The first one is quite easy. 2.7 divided by 27, which is 0.1. And then the next one is 9.125 grams divided by 36.5. 9.125 divided by 36.5, which is 0.25 moles. Let me just correct that a bit. 0.25 moles. So we need to see which one is the limiting reactant. So let's look at the molar ratio now. This says 2 to 6. For every 2 aluminum, we require 6 hydrochloric acid. We can simplify that to a 1 to 3 ratio. Just like a fraction, 2 goes into 2 one time, 2 goes into 6 3 times. So this is really a 1 to 3 ratio. So that means this will need to be times 3 for it to react. We should have 3 times as much hydrochloric acid, 3 times as much, you can see here, hydrochloric acid as we do aluminum in moles. And that would be 0.3. And of course, we can see that we do not have 0.3. Instead, we have 0.25. That means that hydrochloric acid is the limiting reactant, is the limiting reagent. So now we've got part of the question. Now it asks us to find the mass of aluminum chloride. And so let's do that now. So now we know what is the limiting reagent, which is hydrochloric acid. That is our limiting reagent. We determined that by using our calculation earlier. It wants us to find out what mass of aluminum chloride we can make using this reaction with hydrochloric acid being the limiting reagent. The first thing we have to do, like previously, is look at the molar ratio. This is a 6 to 2 ratio. If we simplify that, we divide the 6 by 2, that's going to be a 3. We divide the 2 by 2, that's going to be a 1. So the ratio is 3 to 1. 3 moles of hydrochloric acid will make 1 mole of aluminum chloride. Or in other words, you need to divide by 3 to find the amount of moles of aluminum chloride. And we can do that here. So we're going to divide that by 3, 0.25. Let's use our calculator. 0.25 divided by 3 is 0.08333 reoccurring. But we need to get up, we said, to the mass. And of course, we need to remember that equation which comes up often. You're going to need to do this, Mr. Mole mass. So to find the mass, we need the MR times the mole. Well, what's the MR of aluminum chloride? Aluminum is 27. Chlorine is 35.5 times 3, because there's 3 of them there. Let's quickly put that in. 27 plus 35.5 times 3. And that equals 133.5. So to find our mass, we take the MR, which is 133.5, times 0.0833. Let's do that now. Times 0.0833 reoccurring. And we get an answer of, I'll put this in purple, 11.12 grams, which is the correct answer. So that was a more challenging question because they first asked you to find out what the limiting reactant was, and then they asked you to find out the unknown mass of one of the products. But nevertheless, the method is the same. Using the table method, I call it the table method because you can see all of the values line up in a nice table, and it allows you and your teacher to really structure your answer and understand what it is. And you can use this method for any calculation type question, including titration, amounts of substance, reactant yields, product yields, anything along those particular types of chemistry calculations. Make sure you leave a comment, like and subscribe. Let me know what videos you would like me to do next time. A-Star Science, our GCSE Must Know Chemistry series.